Good afternoon, everyone. Thank you for your patience. We started a little bit late because we understand that parking is a challenge right now. I'm Michael Brown, president of the School for Advanced Research, and it's my pleasure to welcome you to this first event in a series of the Creative Thought Forum focused on the issue of inequality, where it came from, why it continues, and what, if anything, can be done about it. Today, you're getting the big picture view of it, the 10,000-year picture. On May 4th, which is Saturday evening, we have a lecture at the Lensic by Mark Rank of Washington University, St. Louis, and the title of his talk is The Paradox of Economic Hardship Among American Prosperity, or Amid American Prosperity. So if you're interested in that, he's testified before Congress. He's a real authority on poverty, the causes, and hopefully the solutions to poverty in the United States. We do have tickets available for that event. Obviously, there's a lot more seating at the Lensic than there is here. This event is SAR's annual Linda Cordell Lecture. You may hear something about that from our speaker. This honors the legacy of Linda Cordell, the archaeologist who had a strong connection to SAR and passed away some years ago. We're co-presenting this with the New Mexico History Museum. And I'd like to thank Billy Garrett. Billy, are you here? Maybe he's not here, but I'd like to acknowledge the executive director of the museum and his excellent staff for collaborating with us on this event. I also want to thank our generous sponsors. Be patient with me because a lot of them. The Patricia Foshi Charitable Fund, Santa Fe Dining, Dan Marion's UBS Wealth Management, REDW Investments, they manage our endowment. We're very grateful for their skill in that area. Adobo Catering, SAR's Founders Society members, some of whom I believe are here. Newman's Own Foundation, Thornburg Investment Management, the Vortman Endowment Fund, and the Flora Crichton Lecture Fund. These events are made possible by the participation and contributions of our members. So if you're not an SAR member, as yet the security people will be removing you right away. No, actually an easier solution is to check our website, sarweb.org, and look into joining us as a member. We greatly appreciate it. And I also want to acknowledge our board of directors. Do we have any directors here in the room? No? Hands? No one will confess to being a director at SAR. Well, they do a fantastic job, and I have the best darn board of directors in Santa Fe, and I like to acknowledge that publicly. Our speaker today is Tim Kohler, the Regents Professor Emeritus of Archaeology and Evolutionary Anthropology at Washington State University. In addition to being a former SAR resident scholar, Tim has been awarded the Alfred Vincent Kidder Award for Eminence in American Archaeology, and he recently was inducted into the National Academy of Sciences. His recent books include, and these are edited volumes, so he co-edited a book called 10,000 Years of Inequality, and also a second one with Mark Varian called Emergence and Collapse of Early Villages, Model of Central Mesa Verde Archaeology. Friendly reminder, if you've got a cell phone, probably a few of you do, could you please remember to mute them? And I've already muted mine. We will have a chance for maybe 15 or 20 minutes of Q&A after Tim's lecture. So when we've got a microphone that will circulate to people with questions. So please join me in welcoming Tim Kohler.
Hi, everybody. Can you hear me all right back there? Good. Thanks for turning out on a beautiful day. At least it's a beautiful day from the perspective of where I live, which is in eastern Washington. So maybe not for you, but it's great for me. This is a real honor because this lecture is named after Linda Cordell. And Linda was, how many of you knew Linda? Linda passed away about 13 years ago, as you know. Those of you who raised her hand, she was a really interesting and innovative figure in Southwestern archaeology. She was one of the first people to bring simulation to bear on archaeology in the Southwest. She wrote this famous article with Fred Plog escaping the confines of normative thought, which appeared just about the same time I was trying to figure out how one could be a Southwestern archaeologist and what it meant to be. And I would claim, in fact, that there's a kind of tie between this article and the topic of my talk today, which is about wealth inequality, because the way we measure wealth inequality in archaeology, typically, although there are other ways, is to look at disparities in house sizes as an index or a proxy for wealth inequality. And this article is all about looking at variability in the archaeological record. So perhaps it was in some ways due to her that I got interested in this. So, as you know, archaeologists have been working on thinking about inequality for a long time. But the way we have done it in the past was typically to look at wealth objects, where they are in the archaeological record, when they appear, who owned them apparently, and try to track that around and understand. The problem with that is that in one place you might be working with burial information, and another place you might be working with pyramids, and another place who knows. But you've got all this kind of discordance in the sort of information you have available. So I've been trying to lobby for about a decade now that we need to look at this problem more systematically to understand really what's going on with wealth inequality in the past. And the way I've been trying to develop it is to look at these disparities in house sizes. And so imagine you had a site up in southeastern Utah or someplace, and you excavated 3 pit houses like this, and they were all exactly the same size. 11 meters on the floor area, 11 square meters. You could, at that point, take that information and calculate what's called a Gini coefficient, G-I-N-I, which is a tool that economists use. And it scales between 0 and 1, where 0 indicates no disparities. These houses are all exactly the same, and you calculate a 0 from these houses. If, on the other hand, there was a site down the road that had a distribution of house sizes like this, 1 big one, 3 little ones, the way the numbers work out, the Gini coefficient here would be 0.348, as it turns out. So higher. And so you can make a comparison between those two sites, and you can make a comparison between those sites and other sites in other social and cultural traditions based on this disparity in house sizes. So economists have been using Gini coefficients for a century, and they make a fine art of it, and they use it in 2 main circumstances. One circumstance is where they have information about how much money people have, their wealth, their total wealth. They calculate Ginis on that. More commonly, because it's easier to get such data, they're calculated on income. So you'll see graphs like this all the time. This is a rough calculation of what's been happening with income inequality for the last 400 years in the US and the UK. And you'll see that there's a big ramp up here in conjunction with the Industrial Revolution. The Industrial Revolution essentially raised the carrying capacity a lot, and it made it so there was a lot more wealth in circulation, and it was a lot easier for certain people to become much richer. Gini coefficients and how much wealth disparity there is really fundamentally only depend on 2 things. It's real easy. One is how much production there is above the subsistence minimum in a society. If you're in a society of, say, small-scale agriculturalists, and everybody is producing just what they can eat and can't produce anything more, the Gini coefficients will be extremely low because there's no excess, there's no surplus to sort of get passed around socially or get concentrated in some particular hands. Then there's a decline. And that decline begins right around 1914 in both of these countries and in many Western countries. And that probably had to do with World War I, and then it was followed by the Depression, and that was followed by World War II, pretty rough 30 years there. And then coming out of World War II, many countries had progressive taxation systems, so that kept wealth inequality pretty low. But then beginning around 1980 or so, that began to change, and wealth and income disparities began to increase once again. So we're going to see more cycles like this, and trying to explain these cycles is one of the main things that's kept historical economists busy for the last 50 years. And so there's a lot of competing theories out there. And we'll have competing theories for what I'm going to show today, too, I'm sure. So here's the disturbing thing about this to me. It's not so much that 8 people control, at least in 2017, half the world's wealth, which is a shocking figure, right? But that we know these people, we know these faces, because they're not just wealthy, but wealth buys social influence, it buys social prominence, it's a kind of social capital. So the wealth has its fingers in every little pie. And if somebody gets wealthy, then they can become very powerful. So it's a bit of a misnomer. Wealth is a hard quantity to think about. Here in the West, we think about wealth as being essentially money, property, material goods. But we're going to be talking a lot about societies in which those kinds of things are not nearly so important. If you're a hunter-gatherer, you can't accumulate lots of material goods because you're moving around all the time. And even if you couldn't pass them on to your children very conveniently because they're going to be moving around and they can't take this stuff. I don't want your antique chest, Mom, thanks. Same pretty much for horticulturalists who move not as much as hunter-gatherers. These would be small-scale agriculturalists, and they do a lot of hunting. They move around quite a bit as well. But among hunters and gatherers, what's important is how skilled you are, how many offspring you have, how good a hunter you are. These are the things that bring you renown and bring you prestige, bring you additional wives, allow you to have more children. And so there's a whole different spectrum to wealth than just the material wealth we talk about. And let's see. And so I was surprised to hear, I hadn't known this, that you're going to have a book discussion on this book on the left here in about a week, and that the book discussion is sold out. I've never heard of a book discussion getting sold out, maybe only in Santa Fe, and maybe only for this book. How many of you have read this book? Yeah, okay. I ask a lot of people that question, and then the next question is I ask them how they liked it. And almost everybody who's not an archaeologist really likes this book. They think, oh yeah, you have a great field. I love this book. But a lot of people who are archaeologists get a little bit aggravated at it because on one hand, they are wonderful writers. They know how to tell a story. And they have a kind of consistent plot that makes everything hang together very nicely. But on the other hand, they're rather selective in their evidence, and they don't really give a balanced picture about what happened in the archaeological record. And this is partly because they appear to be allergic to anything that resembles a number. And so, so that makes it hard to do work in this field in detail. Anyway, what they do is try to show, and this is admirable in my view, that the way things have turned out in the world today, in which we have very high wealth inequality, maybe is not the way things had to turn out. Maybe there were turning points. Maybe societies could have figured out how to organize their affairs in such a way that there wasn't a high degree of wealth inequality. And then they proceed to pick out a half dozen some societies that did in fact have relatively low wealth inequality. That is, they were pretty egalitarian. And they talk a lot about those. And then they forget about like 90% of the other societies in which there was much higher degree of wealth inequality. And they don't do a good job about explaining the differences between those societies, why some are more unequal than others. And I don't think you can do that unless you approach this from a quantitative perspective. And so that's what I have been working on here. So while archaeologists are busy producing books like this, which are admirable, this is the sort of thing that economists and historical economists and even historians have been doing at the same time, trying to figure out exactly what the Gini was. In this case, I think it's based on income through time. And then once they see this, they can try to explain why we have these differences through time. And all that depends on having a kind of quantitative basis to the conversation. So one of the people who's best known in this field among economists is a fellow named Branko Milanovic. And Branko was the chief economist for the research branch of the World Bank for a long time. He's now sort of semi-retired, I think. I don't know him personally. But he's written a number of really important articles and really important books on the subject. And here's some data he put together that seems to show that, once again, we've got here the United States, that the United States, this time we don't have, on the x-axis here, we don't have dates. We've got a measure of income, average income. And here we have, once again, our Gini coefficient. And so income is increasing as we go this way. So in the United States, wealth inequality increased in the Industrial Revolution and then declined down in here around 1914 and the World Wars and the Depression. And then since then has been going up, especially since '79, has been going up quite a bit. But it's really insightful, I think, to not just think about Ginis, but to also think about what the experience of living in a society is like, take into account not just wealth inequality, but also the average wealth in a society. And that's what this is telling us along here, this axis. As we move this direction, it's people on average are better off. So I think you'll agree that living in a highly unequal society, if many people are starving, is a much more debilitating experience than living in a highly unequal society where almost everybody has enough to eat and is doing well. So the experience of wealth inequality can be quite different depending on the distribution of capital in the society. So the thing that irritates me, though, about Branko Milanovic, I hope he's not here, I don't know this guy, is that he's got this all worked out so nicely for what happens in the last couple hundred years or so. We have the Industrial Revolution, average wealth is increasing, Ginis are increasing, and then it turns around 1914, and Ginis are decreasing, wealth is still increasing, and so forth and so on. And he's got this nice plot here. But then he goes and says, well, what happens in the pre-industrial period? I'm just going to draw some random lines. I don't know what's going to happen. This is, to an archaeologist, it's extremely irritating. And so, Branko, we can do better. We're going to show you how we can do better. And so archaeologists have been working on this approach to trying to understand wealth inequality for, I don't know, about 40 years or so. And here's a couple of the pioneers are Randy McGuire and Mike Smith. And Randy is now working on other things, but still very active. Mike is still doing this kind of work, but also does other things as well. But they were real pioneers in this area, and I want to acknowledge them. Another thing that was really important was about 15 years ago. Sam Bowles at Santa Fe Institute and Monique Borgerhoff-Mulder convened a large group of mostly cultural anthropologists at the Santa Fe Institute, and they asked them to consider what kinds of wealth were available in different kinds of societies, how it was mobilized and what it meant in those societies. And they came to agree that there were something like 3 different kinds of wealth that can be imagined in societies, and that any kind of wealth can be put into one of these categories. The first is embodied, and that includes some things that I've talked about already: reproductive success, hunting success, and so forth. And for smaller scale societies, especially hunters and gatherers, and also horticultural societies, that is extremely important. Then there's relational wealth, and this is something that we wouldn't call wealth today in our society, but we might call something like social capital. So if you have a lot of connections, in the old days, if your Rolodex was very thick, or if you have a prominent position, say, in a Pueblo society, in a religious society or sodality, something like that, and you were required by that position to house ceremonies in your house, that made for a bigger house. And of course, up above, for embodied wealth, if you had more children, that made for a bigger house. And so numbers of exchange partners, sharing partners, numbers of allies in conflicts, and so forth. And then finally, there's material wealth. Material wealth is the kind of wealth we're all familiar with. So the first thing I'd like to say is that when I talk about wealth inequality in prehistory, please don't think of it as being wealth in the way we talk about it today. It's supposed to be including all 3 of those dimensions, and which dimension is most important will depend on what kind of societies we're talking about. Because some of these slides will be showing 10,000 years, there's a lot of variability in the kinds of societies. But they all have something called wealth, so long as you're willing to admit that wealth has different ways of presenting itself in different kinds of societies. So house size integrates all 3 of those dimensions. Embodied wealth includes large families leading to larger houses, relational wealth, lots of kin, supporters, prominent positions. Material wealth, just lots of stuff, big fancy houses. So when we began this work in earnest, we thought, well, this is going to be pretty easy. All we have to do to figure out what's happening in contemporary societies is to talk to some sociologists or people working in the census, and they can tell us what the relationship in contemporary societies is between house size and wealth. Well, guess what? Such a series does not exist. At least I haven't been able to find it yet. And perhaps it could be put together by a great deal of indirect work. But even though we live in a society with lots and lots of information apparently at our fingertips, wealth is a rather closely guarded piece of information and is not something that gets out into public databases very often or very accurately. So we can't easily point to nice graphs showing the relationship between house size and wealth in contemporary societies. But we have indirect ways of doing it, and they all seem to point to the fact that, in fact, people who have high wealth tend to live in big houses, and people who have very little wealth tend to live in little houses. You can all think, I imagine, of exceptions to that rule, but this, on average, is true, and that's the best we can hope for, I think. So here we see an example of the kinds of data we can come up with, and this is a measure of income along on the x-axis here. On the y-axis, it's a measure of floor area of houses, and floor area of houses get bigger regularly as income goes up. I mean, average income goes up. That doesn't prove it, but we see graphs like this for lots of societies, and it's easy to find graphs like this. A few years ago at the Amerind Institute, a sister organization, we put together a group that culminated in this book, and we had about 8 people contributing data to it, and we said, let's have everybody contribute data, and then we'll look at all the data together and see what kinds of patterns we can see in Gini coefficients based on house sizes through time in many places of the world. And so we had, I don't really remember, maybe 150 sites or something like that, and made some nice graphs and learned some interesting things and came out with this paper. And I don't have time to go into great detail on the findings, but I very quickly want to show you some things that were published in this book about the Southwest, because the Southwest is a great case because we have such good chronological control. In the graphs I'm going to be showing you, we have hundreds and hundreds of years in each little time bin. But here in the Southwest, we have maybe a few decades in each time bin. And so we can get much better control over what's going on. And we were particularly interested in seeing, kind of as a proof of principle, how the Gini coefficient would respond to these big, odd structures that we call great houses. This is Pueblo Bonito in Chaco Canyon, and these are great houses up in along the in the Farmington Aztec area here, and over in Mesa Verde area here. That's a very small great house, but it's still a great house. And so we wanted to see if this Gini coefficient would pick up great houses, because if it didn't, it's not going to be very useful for our purposes, would it? So we started graphing Gini coefficients based on house sizes in various areas. This is the Central Mesa Verde, this blue line. This is Chaco Canyon. Wow, something really different is happening there in the 900s and 1000s. This is the Middle San Juan area by Farmington and Aztec. Kind of similar to Central Mesa Verde, but pretty high early on. And then this, excuse me, is the Chusca area. And then if we put them all together, we get this black line here. So we see a lot of variability, and we in fact see a lot of increase in the Gini coefficients right at the time when Chaco is just emerging and beginning to spread its influence. And this high peak here at about 1050 or so represents the spread into Central Mesa Verde of Chaco and related societies. And so we thought this was good, and one of the reasons I'm really interested in the Southwestern data is because in the Southwest, we know so much about what else is happening. So if we look at the relationship, if we look at the relationship between the Gini coefficient, which is this blue blocky histogram here, so it's high here, low here, low here, low here, and a measure of warfare, which in this case is violence that is preserved on human bone. So we know it was lethal in many cases, but not in every case, but still was violence. We see that there's a peak of violence right after a peak in Gini. Well, not quite here because we run out of archaeological record there. But it appears that not only is the Gini interesting in its own right, but Gini has social ramifications for what's going on in these societies. And it could well be that the levels of inequality are getting high enough that there is resentment, there's score settling, and so forth going on. And that is why we have these peaks in violence here. As some of you in the audience know, the story is not quite that simple because history rears its ugly head. And we also have climatic downturns in this period here, in this period here, and in this period here that make the picture more muddy. And now you can say, is the violence due to essentially starvation, poor conditions for maize, or is it due to high inequality? That's really a tough nut to crack. My answer is it is in fact probably both, that those things feed off of each other, and having a high degree, having pre-existing schisms in the society based on high wealth means that the society is sort of not very resistant to the sorts of violence that we see in these times that accompany climatic downturns. So these I would I would suggest are perhaps not incredibly healthy societies from the perspective of being very resilient. So that remains a story, and we'd like to see whether or not that is confirmed or not in other societies. And so now, for the last 2.5 years or so, I've been working with a much larger group of people, not just 8 people, but a couple dozen people, who are in turn working in places all over the globe. And we call this the Gini Project, and we've got a little bit of funding from NSF, and we've met 3 times. This is one of our group meetings right here. This was the first one when we were just trying to put our database together. And of the people here, I'd particularly like to point out Amy Bogart over here, who's also a PI on this project. And she's an invaluable part of the project. So to do a project like this, one of the first things you have to do is put together a database. And the database has to have, you somehow have to have this magic foresight, so that everything you'll ever want to ask of this database will be in it. And you also have to agree that how to measure all the things that you're putting into the database. So it's in some ways the toughest part of having a project like this. And of course, we didn't do it right exactly, but we did it sort of right, and we're starting to get some interesting results. Our very first publication came out a few months ago in the journal called Journal Antiquity, which is a British journal, and we showed what we had at that time with the distribution of sites in the database, and we had about 1,000, I think, at that point. And then a very quick rough graph of the Gini levels in these different portions of the world. This is a little bit out of date because we have roughly 150 more sites now, but it's not too inaccurate. So now I want to show you the results from this Gini project. But before I do that, unfortunately, I have to ask you to learn some terminology. This isn't a terribly technical talk, but there's 2 or 3 little terms that you have to get under your belt. And imagine that you've got a time series of the archaeological record here. And here you have, say, early agriculturalists, and they all have very small sites. And we measure, in the database, we have a slot in which we talk about how many levels there are in that society. How many different site sizes are there? Just 1. So n of levels in this society is 1. And which level is this particular site? It's also 1. And if we wanted to sum those together and talk about something called social advantage, SA, that would be 2. 1 plus 1 is 2. See, it's not that hard. And then you go over here, perhaps at a later time in the same area, you begin to see some larger sites starting to emerge. And this would still be which level 1, but this whole system here would have which level 2. And this particular site here would be called an apex site because it's the largest site in its settlement system. And all these little ones here, including those and those and those and those, would be called basal sites. And the settlement system continues to grow. There'd be many, many little sites out there that I haven't put on this graph. And eventually we get apex sites that are something like, well, in this particular example, which level 4, because there's 4 levels, and this is on the 4th level. And the SA for this system would be SA of 8. So SA is kind of a weird term, but rather than say social advantage all the time, I'm going to use it. This term social advantage, this construct, is sort of an ordinal estimate of the minimal size of the connected network of people whose work and whose interactions create wealth and also create the disparities in wealth in a society. If we had population measures for all our societies, we would probably use those and not SA, but we don't. And it's much easier for archaeologists to estimate n of levels and which levels, and therefore SA, than it is to estimate the population of a settlement system. So where we do have the population, we know that SA and polity population are very strongly positively correlated. It's hard to talk in Santa Fe if you're not used to 7,000 feet elevation. Sorry. Okay, here's the first hard result. And it's a complicated graph, so I just want to try and walk you through it a little bit. This represents the time in various portions of the world when the Neolithic arrives in different areas. Now, you'd like to see a graph like this with something like AD or CE or BC or BCE or something like that here. But this is time, but it's a very strange version of time. We call it delta years, and it relates to the time between the site, the dates of these sites, and when agriculture arrived in the neighborhood of these sites. So a site with a delta year date of 2000 means that in the area where that site was located, agriculture arrived 2,000 years before that site was occupied. Does that make sense? So these negative dates here are pre-agriculture occupation. And this is the arrival of agriculture. And this puts all these different world areas on the same footing, because there's no event more important in all of world prehistory for eventually effecting wealth inequality than the development of domesticated plants and animals. I'm going to nuance that statement later in this talk, but right now you can take that for granted, and that's why we set the clock here with the Neolithic rather than, say, the development of iron or the development of states or something like that. Okay, so what can we learn from this? There's too much here, I'm sorry. But first thing you'll see is that there's Gini levels, that the smallest sites, the SA equal 2 sites, always have very low Gini coefficients. They just never get high on average. Of course, there might be a few weird ones, but in general, they never get very high. But what does get high, the Gini coefficients get high at the bigger sites, those that have an SA level of 8 to 10, or even 6 to 7. This is 8 to 10, this is 6 to 7. Or we can, if we prefer, track the apex sites, which are always the largest sites in their settlement systems, versus the basal sites, which are the smallest sites. So the basal are yellow and apex is green. And we can see that most of the action is on increase in Ginis is in the bigger sites, in the apex sites. Now, this seems like such a really obvious thing, but I don't think I've ever read archaeologists making that point. But it's a super strong pattern in the archaeological record. And it kind of implies, and we'll see this more later on, that one of the things that makes wealth inequality possible is the growth of these settlement hierarchies that rewires the way that people interact with each other across the landscape relative to the situation when everybody was living in little hamlets of the same size. And understanding that, how that works and why it works that way, is sort of the next frontier in this work now that we've pointed out that this is an incredibly important part of the process. One other thing you can glean from this, many things you can glean from this, is that not much happens right here, right? It's about 1,000 years or maybe even a little more before we begin to see much response in the Gini dimension to the domestication of plants and animals. You will read in many classic archaeological texts that as soon as people develop domesticated plants, that inequality appears. It's just not true. At least not based on this proxy. There's a lag of about 1,000 years in some areas, even more in other areas, before inequality starts to appear. So that's something for you to worry about. If inequality isn't due to this apparent increase in production, what is it due to and why is there a lag? Let me know. I mean, I think I know. I'm always interested to hear other theories. If we just break this up into big world regions, here's Asia. Of course, Asia includes sites in Jamon, Japan, sites in Korea, sites in Southwest Asia, Iraq, Iran, Syria, Lebanon, and so forth. But we see pretty much the same patterns. We see this difference between the apex sites and the basal sites. We see very strong high Ginnies in some of the latest big sites, the 8 to 10, SA 8 to 10. And we also see that, generally speaking, the SA2 sites, so there's a little bit of increase, but only very late, like 4,000, 5,000 years after the development of agriculture. For the most part, those are very egalitarian. So if you wanted to imagine an egalitarian past, all you have to do is teleport yourself into one of these small sites, and you'll find a very egalitarian past. But don't make the mistake of walking right next door, because perhaps at the big site right next door, things will look very different, and there'll be much higher degrees of wealth inequality at that site. Okay, Europe, pretty much the same picture. I don't need to talk about it in great detail. Europe has a peculiarity in that 6 to 7 is what gets really big here on the SAs, because we don't actually have very many 8 to 10 SA sites. But we still see the same gap between the apex sites and the basal sites. In fact, it's even bigger. And the SA equal 2 sites still remain very low. By the way, keep your eye on this gap, because the size of this gap between the apex and the basal sites is an estimate of how much the settlement system is inflating the Gini levels in different regions of the world and for different site types. The difference between those is the measure that we're going to call the Paulitti scale effect. Okay. And then finally, the Americas. Pretty much the same story. Here, perhaps the SAs are growing a little, SA2s are growing a little bit more. Here's the difference between the basal and the apex, and some of the big sites get extremely unequal. So I guess you know the pattern right now. We don't have quite enough sites in Africa or in Oceania to be able to graph those sites in the same way. We put them into the first plot, the world plot, but we can't really pull them out and examine them separately simply because the sample sizes are so small. So now we're going to look at the relationship between the apex and the basal sites through time in different regions. So this is what I promised to call the Paulitti scale effect, and it represents how much more unequal it would be if you walked from a small site in a settlement system to a big site in that same settlement system at the same period of time. And you can see that in Europe, for example, it reaches a really high level, almost a 0.25 difference in Gini. Worldwide, sorry, this is Asia. Asia, not so much until very late. Americas, we have this strange downturn here, and I have to point out there's a quantitative thing going on here. That is that the smoothing function we use, called the Less line, is quite sensitive to values right on its boundary. So this is actually due to a couple sites that are kind of outliers, and the same for this. So really, the story starts here, and we have low Paulitti scale effects in the Americas, really the same worldwide, and then increasing. So you can see from here, it takes about 1,500 years or so before the Paulitti scale effect begins to really take off in most of these areas. And so that's due to the development of these settlement hierarchies. Okay, now we come to a point in the talk where I'm nearly done, but the part I haven't talked about yet would be incredibly boring if I went into it in enough detail to satisfy my peers out there who are archaeologists. So instead of showing you the results of endless regressions, I've drawn a few kind of little cartoons to try and distill what I think are the results of those. And the story sort of starts with the end of the Pleistocene. The Pleistocene was cold and dry, you know, ending about 12,000 years ago, last ice age. Climates were very harsh and highly variable. Excuse me. What this shows here is exactly how variable they were. What this shows here is that the Holocene, the last 12,000 years, are much warmer than the Pleistocene. And what this shows here is that the Holocene is a whole lot less windy than the Pleistocene was. And all those things mean that we don't ever want to leave the Holocene if we can. If we have a choice, let's not go back to the Pleistocene. It was really pretty miserable, and human populations never grew very much in most areas in the Pleistocene. So the settlement systems at the close of the Pleistocene were all these sorts of things I've shown you already, SA equal 2 sites, all very small. The Holocene rolls along, though. Things get warmer, more stable, less variable from year to year, and that means that you can stay in one place much more easily. As you stay in one place longer, here that's called sedentism, that has an effect on population growth. And also in many of the areas where population is growing, conditions were much more profitable for people. They could, if they were hunting and gathering, there was more to hunting and gathering. If they were starting to do agriculture, production was much higher. So there was this interplay between sedentism and population growth that began right at the beginning of the Holocene. But immediately, it doesn't have any effect on settlement systems, except maybe perhaps you'd have a few more of these little dots on the landscape. You wouldn't have a hierarchy of settlements. Not yet. But it doesn't take very long before agriculture begins to appear as a way of intensifying production on this place you are now living in and staying in for a long time. And you begin to develop plant and animal domestication as well. And as that happens, there's an interplay between that, a feedback between that and degree of sedentism. If you're beginning to raise animals and plants, you don't want to move all the time, especially if you've made marks on the landscape, you've improved your areas for production, you're more and more tied to that place. Your population can grow all the faster because of this feedback, and you increase in sedentism. And not quite yet, but almost, we're going to begin to see different kinds of settlement systems. In fact, beginning, about 1500 or so years after the development of agriculture in most areas of the world, you begin to see these more hierarchical settlement systems. And as you already know, by that time, we see some of the first sort of durable or persistent inequality. Not very high, but higher than it was previously. Then things roll along. We begin to see stronger, more marked hierarchies. This was the one I showed you already. This goes along with population growth. I'm going to leave it as homework for you to figure out why it is that as population grows, the settlement hierarchy also grows. That could be a question for discussion later on. As this process proceeds, as the political variability becomes more marked on these landscapes, we also see that how societies are organizing themselves, the nature of their governance makes a difference on the degree of inequality. And we also see that technology makes a difference on inequality. For example, the advent of iron and the advent of bronze both have a noticeable effect on increasing inequality when they begin to appear in their areas. However, and this is interesting and unanticipated, shortly after that uptick, in fact, those societies become more equal after that. So it's very complicated, and we're still trying to figure all this out. And by the way, if you are interested in this project, we hope to have some papers out by the end of the summer in the Proceedings of the National Academy of Sciences. These are under review right now, so if that review process goes well, you'll be able to read all about it there. Okay, well, in overview then, because I'm almost at the end of my time, we had some surprises in this project. First of all, farming by itself doesn't cause inequality. Farming does cause an increase in population, which eventually causes inequality in conjunction with subsistence intensification and in conjunction with the growth of settlement hierarchies that both population growth and subsistence intensification channel the landscape into. So those two things, a measure of intensive land use and SA are the two strongest predictors of the increasing household inequality in this entire project. Intensive land use starts a little bit before increases in SA, but then they work side by side. They kind of co-evolve together. That, by the way, is a Chaco Great House. Okay, this is, I think, my final slide, more or less. Do you remember how irked I got at poor Branko Milanovic at the beginning of this talk? Well, he was making graphs for the last couple hundred years that showed that if we put average wealth along the x-axis and Gini, degree of wealth inequality, on the y-axis, that there was a very patterned relationship in the last couple hundred years. And he actually marked a sort of cyclical relationship between that through time. But then he said, we wouldn't expect to see anything like this in prehistory. Well, here we have a measure of wealth inequality on the x-axis, and here we have a measure of average wealth in sites. And what it is, okay, so if disparity in house sizes measures wealth disparities, then the average, or in this case, the median house size, gives us some measure of the average wealth in a society. So what we've done here is look at the average wealth on the x-axis of each of these areas for each of these districts here. And then we've looked at the relationship between those, and we've graphed the time here in color. So you can see, for example, in Asia, we have the early dots over here, the late dots over here, and we see a very patterned relationship between small, early households that are equal, very little or no wealth disparity, to much larger houses on average that have much higher wealth disparities. That, to me, looks like a pretty strong pattern, not something that I would just put some lines like that on. And we see the same in Europe, by the way. We see kind of the same in Mesoamerica. It's a little more complicated. We see the same in South America quite strongly. Weirdly, we do not see that pattern in North America. So that remains a very interesting research avenue for somebody to explain. But all I would say at this point is, if you're not aware of this effect, you can't attempt to explain it. So we're attempting to make people aware of this effect so that we can try to explain it. Well then, here's Branko's graph, prehistory, actually even pre-industrial. And my closing comment is, ha ha ha, not so fast, Branko. There is more there. There's a lot to learn about the archaeological record. We've gotten much more excavation going over the last 20 years, much better dated than it used to be. And we don't have to have these sharp distinctions anymore between times when people had writing and times when people didn't have writing. We've got many of the same processes going on both sides of that divide. We just have to learn how to decode those processes from the archaeological record. And we can't rely on historians to do it for us. We have to do it ourselves. And so this is a step in that direction. And the other thing I'd like to say is that you don't see many archaeological presentations in which people try to have a graph representing what's going on in the world. It's insane to try to do that. Nobody does that. But I think we're going to see more of that. I think that we're at the dawn of a sort of world archaeology where we try to put these world relationships into assimilation with each other to understand better their differences, their similarities and their differences. And so this is a step in that direction. So I've already said this, I think. Economic processes, in closing, do not start with the Industrial Revolution. Pattern relationships between increasing income and increasing wealth differentiation can start to be glimpsed across the entire span of the Holocene. Okay. That's it. Thanks very much.
We have time for a few questions. There's a lot to work with here. Mary, I see a hand up over there. It's Tom Johnson, as a matter of fact.
You are dealing with timescales of thousands of years.
Yes.
Could that methodology, the Gini methodology, work on a shorter term? I'm thinking 150 years, and here in the United States, we have the Sanborn Fire Insurance maps, which tell us a lot of information about dwellings. We also have the census manuscripts, and can we put those two together to track what you're talking about in America in the last 150 years?
Thank you for that suggestion. I was not aware of those resources. That's really interesting. I might try to write those down after we're done here. But yes, of course, this could work on higher temporal resolution. That's one reason I showed you the Southwestern data, to show you that when we do this exercise at high temporal resolution, we see that there's a lot of variability up and down, and we can understand why that variability happens. We have in the Southwestern case, we have the rise and spread of the Chacoan system. Then we have the collapse of that system, partly probably because of climate issues. And then finally, we have a collapse of the entire northern Southwest, once again, probably due at least in part to climatic inconveniences. So the point I'd like to make, and thank you again for that, is that if we could look at each of these regions in much more spatial detail and in much more chronological detail instead of these huge graphs I was showing you, we would see, I'm sure, that same kind of variability up and down. It's just that it looked like a smooth progression because of the scale of the observation. When you've got the whole world and you've got thousands and thousands of years, it's useless to try and show the data in high resolution. You just have to try and pull out the big patterns. But I hope that people will continue to apply these sorts of techniques, but at finer chronological and spatial detail.
Well, we have a gentleman here. Okay. And then harder to see people up in the top because of the lighting.
On one of your graphs, you showed a relationship between what was going on in a culture versus violence.
Yes.
Tell me how you measured violence in ancient cultures.
Good question. Until the 1990s, archaeologists in the Southwest would routinely excavate human remains when they excavated archaeological sites, and they would routinely have a physical anthropologist look at those bodies, those sets of human remains. And one of the things the physical anthropologist would note were there any marks? Well, they'd try to figure out what the cause of death was if they could. And so, if there was a blow to the head, that would be pretty obvious. If there were parry marks on the arm, that would be pretty obvious. And so we counted up all those things that we could find in sites for the last 50 years, stopping in 1990 because of NAGPRA laws. Archaeologists no longer routinely excavate or analyze human remains. So, but looking at that historic record, the published record of things, we just tallied all those sets of remains with evidence of violence, yes. Another set, no violence, no. And so we built a proportion of the sets of human remains with violence, and that's what was graphed through time. And that was just for the northern Southwest.
Okay.
So my sense is you're talking about cultures internally growing, but I'm also wondering about cultures next door to, that is the idea of either invasion or trade, or is there any evidence about how much influence there is just internal versus something happening from the outside?
Right, that's a good question. One of the comments I would make right off the bat is that when I made the claim that SA is an ordinal measure of the human interaction network that is responsible for creating wealth and for distributing wealth, in the actual paper from which I took that quote, I say it's a minimal estimate because it could be that a polity is in close association with a polity next door with exchange relationships, or they could be highly competitive with that polity. And that would, in fact, have the effect of increasing the size of the network of interacting people in a way. And so I feel that these processes are probably very important, but we haven't tried in this first blush approach to these data, we haven't tried to pull that out. I'm not exactly sure how to do it. I think I could perhaps begin to do that looking at a smaller area like the northern Southwest.
Do you have a question?
Yes, ma'am, over there. I'm sorry to point.
Okay, I don't have a mic, but I'll just ask.
Project.
So you're using house size as a proxy for wealth differentiation in this
That's right.
study?
Yeah.
And so how do you know that Chaco and great houses are actually houses and not communal structures or structures that are being used for some other type of use? And that would probably be something that applies to the whole Chaco region or maybe, other contexts as
Yeah.
well.
This is a really old problem in southwestern archaeology, as you probably know. Many of the larger, well-known great houses were excavated early on in the history of southwestern archaeology using techniques that weren't terribly good. But a few have been excavated more recently, and the great houses seem to contain domestic debris within them. And they seem to have all the same features that one would expect in a standard smaller sized household. But it's just that these spaces are scaled up dramatically, and especially the storage spaces are scaled up dramatically. And so, yes, I think one can't be absolutely certain, but the sort of indirect lines of evidence that we have available to us suggest that they had a domestic function, but that they also had these other functions. I'm sure that they had, the relational importance, to use the terms I was developing in the talk, were extremely important for Chacoan sites.
Nope. Any
Came over
questions
here
over
to
on
give
that
this
side?
side a chance. Any questions over here? Here you go.
I have a question I can project. I have a question on that last series of graphs that showed the various places in the world, and you said, look at this interesting pattern for North America.
Yeah.
As I'm a Mesoamericanist, but I obviously live here in North America and observe this pattern. Is the North American pattern because what is lacking there is a more complex site hierarchy, whereas where I work in Mesoamerica, you have a very deep site hierarchy, of course, very large site hierarchy. You have little villages and everything to, call like Mohulla and Tikal. So with all this social relationships, which are built on this site hierarchy, isn't it what that North American graph is actually showing is you don't have a lot of site hierarchy, so it's kind of flat.
Yeah, I think that is a big part of the story, indeed. Another thing that I would say is that many parts of North America had a peculiar history, Maize agriculture sort of burst onto the area around what's now St. Louis, the American Bottom, in around 900 or so, and they already had a rich production of locally developed crops. But maize changed a lot of things for them, and they became highly dependent on maize. But then climates deteriorated radically beginning in the 1200s, and it made it more difficult for them to produce the surplus. Remember, I said that inequality depends first of all on the size of the surplus, and second, but only second, on how that surplus is distributed. And so I think that the amount of surplus to be redistributed here in North America was generally smaller than in the more, not that these areas didn't all have climate challenges at one time or another, but this hit at a particularly bad time for the North American production systems in the Southwest and in the East. So there's that. I think production was low. But secondly, I have to admit that there's a bit of a measurement problem for North America that affects this graph in particular. For all the areas that we have across the world, there's two major places where the house form is a kind of longhouse instead of just a nuclear house. And in a longhouse, you have maybe 4, 5, 6 nuclear families, or at least households, living in one big structure. So how do we measure that? We consider those long structures to be the houses, and we create the Gini based on that. But there's also variability within those households that we're not measuring when we do it that way. So we may be underestimating the Gini for those places that have long houses. Some of those are on the Northwest coast, and some of them are in Eastern North America post-Chaco. And so that could be affecting this downturn here. And there is finally one more problem. Archaeology is messy. When we look at this dimension on all these graphs, we're controlling for variability in the kinds of structures that families are tending to use. And that's because within a particular settlement, everybody's using a nuclear household, or everybody's using a longhouse. You don't get mixes of those things. So when we compute the Ginis by site, it doesn't matter if it's a longhouse or a nuclear family household, because we're still looking at the differences between those things, whatever they happen to be. But on this axis, that makes a difference. And so one of the things that I'm worried about here is the extent to which, including longhouses from Eastern North America, which are late prehistoric, is pulling that line down. It's an instrumental kind of issue. Or I shouldn't say necessarily pulling it down, but just causing variability in it, right? So it could even be making it higher than it should. I don't know, but I'm not worried about this dimension, but I'm a little bit worried about that dimension for that reason.
Up here, Michael. Up
Okay.
Here you go.
I can just yell. You've indicated that about the gradual transition from hunter-gatherer into agriculture, that it wasn't a curtain that came down and moved along. Obviously, sophistication increased in terms of storage. What I'm wondering is if you have any hypotheses about how people get control of that increased sophistication of storage and how they then begin to perhaps take power and move up in the hierarchy.
So you're asking for insight into a really critical time in the archaeological record, and it would be roughly the point at which we begin to see the very first site hierarchies, because that's probably about the same time when people begin to grow their storage. And one of the first things that happens, like take Chaco. When Pueblo Bonito was founded and started to grow in the mid-800s, at first it looked like any old Pueblo I site. And then in the mid-800s, a couple households massively added to their storage capacity. And it seems like from there, everything snowballed. So it was the addition of those storage rooms, first of all, that were a very important step. So let's assume that something similar might happen in other areas. What would have caused those households to add that storage area? And how could they have gotten away with it, so to speak? I mean, one of the things, here's an interesting thing. Along with several people in this room, I worked on a project called the Dolores Archaeological Project in southwest Colorado, and we excavated tons of sites that dated between about 8600 and 8900. Most of them would be called Pueblo I, so they'd be later ones, especially pretty contemporaneous with the earliest portions of Pueblo Bonito. We never see anything like that happen up in the Dolores area. And instead of seeing an increase in Gini coefficients through time in the Dolores area for those 300 years, things are really pretty flat. Not much increase at all in the Ginis. But one thing we did see, in this, sorry, I'm running out of steam here. I got to get some more water. What did I do with it? One thing we did see is that there was, we had sites that were small sites that didn't have any kind of ritual structures at them. The households in them had higher Ginis, had more variability in size than the households in the villages, which had less variability, and the sites in the villages were, I mean, the houses in the villages were always right next to big ceremonial structures, you know, like a great kiva or an oversized pitch structure or whatever. So the possible hypothesis that grows out of that observation is that in the villages, there was so much ceremonial redistribution of surplus that nobody really got a material edge over any other household. So it was only after Pueblo I in that area of the northern southwest where Ginis begin to soar, and that's when the Chacoan system intrudes, I would say invades, the Central Mesa Verde area. So why didn't that happen in Chaco? Something happened that made it possible, made it socially acceptable for some households to grow much larger storage areas than others. What that was, I don't know, but somehow it wasn't subject to that apparent ritual redistribution that we were seeing in the Pueblo I societies further north, which did not develop these big Gini coefficients until much later. It's a super question, right at the core of the issue.
Time for one or two more questions. Well, I'll go over here.
Yes, excuse me. Looking at this South America versus Asia or any of the others, why is there such a paucity of data points in South America?
Well, at least two things are going on. One is that we only had one archaeologist from South America collaborating on our project, and there were certain human limits to how many structures he could code. I think that there are probably quite a few more out there that we could enter into the database, but we had a person power problem. Secondly, there are large swaths of South America in the Amazonian basin for which we have almost no architectural evidence, and yet we know that there were probably, at least at various times, many people living there, and we know that those societies were probably also rather hierarchical. At least that's the intuition from looking at what we can see. So the South America story remains to be fleshed out. Yeah.
Let's do one more from somebody who hasn't asked a question. I'm sorry, I see. I guess I'm closer.
Hi there, Tim. This is Vern Scarborough. Good, very interesting presentation for sure. I was just wondering about the fact that you've somewhat homogenized many environments by working in these continental units. And I'm wondering if you were to break it down into more climatically cross-cultural divisions, if some of your evidence might appear a bit differently. Just
Yeah, do you have, Vern, thanks for coming. Vern could almost be giving this talk, he'd give a different talk, but it'd be just as good, maybe better. But do you have, of course, for these broad brush, are you saying that there's environmental variability in Asia? I just want to make sure I understand your point. Yeah, of course, yes. And we do need to look at those questions. And one of the things that I would point out is that in the regressions that I didn't talk about, we see that there's that it's hard to explain why there's variability among Gini coefficients before agriculture. And the reason I think that we don't have strong regression relationships for that period is because the way that the hunter-gatherers were using the environment was in fact much more keyed into resource distributions than the later farmers were. And so that, where you had a very stable resource patch and where that resource patch was pretty constant and where it was worthwhile for you to defend it, there you could develop some unequal relationships like you did on the US Northwest coast, like you did along the Fraser River, for example, in British Columbia, along the Columbia River in Washington State, where I'm presently living. So stable and highly productive resource patches that were defensible resulted, even among hunters and gatherers, in high Gini coefficients, high degrees of inequality. But those places were relatively few and far between, and we don't have resource distributions in our database in such a way that we can use them as independent variables in the regressions. So that's why we can't see strong relationships for understanding the way that inequality grows in hunter-gatherer systems. But especially in hunter-gatherer systems, but even in later systems, if you know enough about my work to know that I think the environmental dimension is incredibly important. It's just that we haven't gotten there yet with these data. So.
Why don't we end this part of the event? If you'd like to stay behind and ask questions, I'm sure Professor Kohler would be happy to answer. Please join me in thanking Tim Kohler for a great talk.
Thank you.